Okay, good afternoon, ladies and gentlemen. Okay, welcome to the course Wireless Communications and Machine Learning. It is an online course. The total length of the course is 75 minutes. I will split the course video into 3 parts, and each part has 25 minutes. Okay, at the beginning, let us see the new announcements of our course. Okay, there is only one new announcement today. Okay, this week's classes have been changed to online classes. Hello everyone. Yesterday, March 7th, 2021, my body had some problems. I asked my neighbor to call an ambulance for me, and I was sent to Dalingsiji Hospital for treatment. I was discharged at 9 a.m. this morning. After the doctor's diagnosis, he thinks I should take more rest. I have requested leave from the department from March 8th, Tuesday, to 11th, Friday, 2022. All courses during this period will be changed to online courses. I will videotape the content of the course, upload it to YouTube, and announce the URL on the eCourse2 website. Students do not have to come to the classroom to attend class. I apologize for any inconvenience caused. Best regards, Wei Zhen. Okay, let us next see the previous class progress. Okay, in the previous class, we have taught to chapter 1, slides page 17, example 1, and equation 2. Okay, but now I do not have a blackboard, so I use the word instead. Okay, to write down or type down the English words and the equation one by one. Okay, on an Word file, Microsoft Word file. Okay. Okay, problem A. Find the stationary reward mean mu I for I is equal to 1 and 2. Problem B. Find the channel index permutation sigma. Okay, let us look at the solution. Okay, this is the solution for problem A. The stationary distribution pi1, okay, pi1 is a vector, is the row vector such that okay, pi1 is equal to pi1 times p1. Okay, this is equation 3. Okay, where P1 is the transition probability matrix of channel 1. Okay, then let the row vector pi1 being equal to pi1 of 0 and pi1 of 1. Then okay, then pi1 of 0 times pi1 of 1. Oh, no. Sorry, the vector pi1 of 0, pi1 of 1 is equal to pi1 of 0, pi1 of 1. Okay, these two vectors are all equal to pi1. And times the matrix P1, which is equal to 1 second, 1 second, and 1, 0. Okay, then it is equal to, or you can expand this vector, okay, times by this matrix. Then is equal to, this is equal to 1 second times pi1 of 0 plus pi1 of 1. And the second element is 1 second times pi1 of 0. Okay, this is equation 4. Okay, therefore, we can find our stationary distribution by solving the following linear system. Okay, first is 1 second pi 1 of 0 plus pi 1 of 1, which is equal to pi 1 of 0. Okay, here. Okay, the second equation, the sixth equation is 1 second times pi 1 0. Okay, it's come from here. Is equal to pi 1 of 1. Okay, which is come from here. Okay, subject to pi 1 of 0 plus pi 1 of 1 is equal to 1. Okay, because the total probability must be equal to 1. Okay, that is, in the first channel, the probability of state 0 and the probability of state 1, their sum must equal to 1. Okay, then putting these three equations together and moving all of the variables to the left-hand side, we get the following equations. We get the following linear system. Okay, the first equation is 1 second times pi 1 of 0 minus pi 1 of 1 is equal to 0. Okay, this comes from this equation. Okay, equation 5. Okay, we call this equation equation 7. Okay, the second one, the second equation is 1 second times pi 1 of 0 minus pi 1 of 1 is equal to 0. Okay, this equation comes from equation 6. and we call it equation 8. Okay, and the third equation is pi 1 of 0 plus pi 1 of 1, which is equal to 1. And this equation comes from this equation, and we call this equation equation 9. Okay, clearly equations 7 and 8 are the same. Okay, you can see this equation and this equation are the same. Okay, therefore we can remove one of them. For example, we can remove equation 8, and the remaining equations are equations 7 and 9. Okay, the new linear system will have the same solution, okay, as the old linear system. Then adding equations 7 and 9 together, we can get okay, adding equations 7 and 9. So first term, 1 second pi 1 of 0 plus pi 1 of 0 is equal to 3 second pi 1 of 0. And for the second term, minus pi 1 of 1 plus pi 1 of 1 is equal to 0. And on the right hand side of the equations, 0 plus 1, okay, is equal to 1. Okay, so we can get this equation 3 second times pi 1 of 0 is equal to 1. And it implies that pi 1 of 0 is equal to 2/3. Okay, we call this equation equation 10. Okay, and pi 1 of 1 is equal to 1 minus pi 1 of 0. Okay, this comes from this equation. Okay, pi 1 of 0 plus pi 1 of 1 is equal to 1. That is, the total probability must be equal to 1. Okay, and it is equal to 1 minus 2/3, and is equal to 1/3. Okay, because we have find found that pi1 of 0 is equal to 2/3 in equation 10. Okay, so we have found the stationary distribution for channel 1. And the stationary reward mean mu1 is okay, mu1 according to the definition on the slides. Okay, you can go to the slides and see. Okay, let us review the slides. Okay, please open the slides chapter 1 and okay, and turn to page 17. Okay, you can see that pi I is equal to summation S is in capital SI and S times pi I of S. Okay. So mu1 is equal to the summation okay, small s in capital S1 and S times pi 1 of S. Okay, like this, where the capital S1 is the state space of the channel 1. Okay, then we know that it is equal to first state S is equal to 0 or 1. We have told you this in the previous class. So first S is equal to 0 and times pi 1 of S. Okay, pi 1 of 0 and pi 1 of 0 is equal to 2/3. Okay, we can write the pi 1 of 0 here and plus the other state is equal to 1, so it times the pi 1 of 1. Okay, like this. Okay, then the first term is equal to 0. Okay, it is clearly. And the second term is equal to pi 1 of 1. And from equation 11, pi 1 of 1 is equal to 1/3. Okay, so we can just copy this value here. Okay, so this is equal to 1/3. Or I think I need to write more detail. Okay, this is equal to pi 1 of 1. Okay, like this. And we call this equation equation 12. Okay, then we need to find the channel 2's stationary distribution and the stationary reward mean. Okay, similarly, okay, we can find that Oh, sorry, similarly. Okay, we can get this equation. Okay, copy this equation and paste here. Okay, and change 1 to 2. And we call this equation equation 13. Okay, this it is 25 minutes. Let us take a break.